The dark side of the moon, also known as the far side of the moon, is the hemisphere that is always facing away from Earth. It's called the dark side not because it's always in darkness, but because it's the side that is never visible from Earth due to the moon's synchronous rotation. In other words, the moon takes the same amount of time to rotate on its axis as it does to orbit around Earth, so the same side always faces us. While the side of the moon that we see from Earth has been extensively studied by both human and robotic missions, the far side of the moon has remained largely unexplored until relatively recently. The first spacecraft to photograph the far side of the moon was the Soviet Union's Luna 3, which captured images of the previously unseen hemisphere in 1959. Since then, various other missions have flown past or orbited the moon and taken more detailed images of the far side, including NASA's Lunar Reconnaissance Orbiter and China's Chang'e 4 mission, which successfully landed a rover on the far side in 2019. One of the most notable features of the far side of the moon is the South Pole-Aitken Basin, which is the largest known impact crater in the solar system. It measures approximately 2,500 kilometers in diameter and is thought to have been created by a massive asteroid impact around 4 billion years ago. The basin is so deep that it reaches below the moon's crust and into its mantle, making it an important target for scientists studying the moon's interior structure and history. Another interesting feature of the far side of the moon is its lack of maria, which are large, dark, flat areas on the moon's surface formed by ancient volcanic eruptions. The near side of the moon has several maria, such as the famous Sea of Tranquility, where Apollo 11 landed in 1969, but the far side has very few. This has led some scientists to speculate that the far side's crust is thicker than the near side's and therefore less prone to volcanic activity. Despite its relative lack of maria, the far side of the moon is still home to a variety of other geological features, such as craters, mountains, and rills, long, narrow depressions. Some of these features have been named after prominent scientists and explorers, such as the Apollo Basin, which is named after the NASA program that first landed humans on the moon. In addition to its geology, the far side of the moon has also been the focus of scientific interest due to its potential for harboring water. In 2018, scientists analyzed data from NASA's Moon Mineralogy Mapper instrument on board the Chandrayaan-1 spacecraft and found evidence of water molecules trapped within the moon's mineral grains. This discovery could have implications for future lunar exploration, as water is essential for sustaining human life and could be used as a resource for fuel and other materials. In terms of how the moon formed, the prevailing theory is that it was created around 4.5 billion years ago when a Mars-sized object collided with Earth. This collision sent debris flying into space, which eventually coalesced into the moon. However, there are still many unanswered questions about the details of this process, such as how the moon ended up in its current orbit around Earth and why its composition is so similar to Earth's despite forming from a different body. Despite the many mysteries surrounding the dark side of the moon, there are plans underway to explore it further. NASA's Artemis program aims to land astronauts on the moon's south pole by 2024. And China has plans to send more rovers and possibly a manned mission to the far side in the coming years. These missions will provide new opportunities to study the moon's geology, composition, and potential for supporting human exploration and settlement. One of the challenges of exploring the far side of the moon is the lack of direct communication with Earth. Because the moon blocks radio signals from Earth, any spacecraft or rover on the far side must have its own relay satellite in orbit around the moon to send and receive signals. This was the case for China's Chang'e 4 mission, which deployed a relay satellite called Queqiao in a halo orbit around the moon to communicate with the lander and rover on the far side. Another challenge is the harsh environment on the moon's surface, which is exposed to extreme temperatures, radiation, and micrometeoroid impacts. These conditions require spacecraft and rovers to be specially designed and equipped to withstand them, and also present challenges for human exploration and settlement. Despite these challenges, the exploration of the dark side of the moon holds great potential for advancing our understanding of the moon's formation and evolution, as well as its potential for supporting human exploration and settlement. As we continue to explore and learn more about our closest neighbor in space, the mysteries of the moon's past and future are sure to captivate and inspire us for generations to come. Another interesting aspect of the far side of the moon is its potential for astronomy. Because it is shielded from the radio and light pollution from Earth, the far side provides a unique opportunity for telescopes and other instruments to observe the universe in ways that are not possible from Earth. In fact, there have been proposals to build a radio telescope on the far side of the moon, which could potentially detect the very first stars and galaxies that formed after the Big Bang. Beyond the scientific and astronomical potential of the far side of the moon, it also holds cultural significance as a symbol of human achievement and exploration. The first human landing on the moon, which occurred on the near side in 1969, was a defining moment in human history and a testament to our ability to explore and push the boundaries of what is possible. As we continue to explore the moon and beyond, we carry on this legacy of exploration and discovery, inspiring future generations to dream big and strive for new heights. In conclusion, the dark side of the moon is a fascinating and mysterious region that has captivated the imaginations of scientists and the general public alike for decades. Through the efforts of robotic missions and upcoming human exploration, we are gaining new insights into this enigmatic region and advancing our understanding of the moon's history, composition, and potential for supporting human exploration and settlement. As we continue to explore the far side of the moon and beyond, we push the boundaries of what is possible and inspire future generations to pursue their own dreams of exploration and discovery. Furthermore, the exploration of the far side of the moon could also shed light on the origins of life on Earth. The moon's surface is a treasure trove of information about the early solar system, as it has remained largely unchanged since the time of its formation over 4 billion years ago. By studying the moon's geology and composition, scientists can gain insights into the conditions and processes that shaped the early solar system, including the formation of Earth and the other planets. One of the most intriguing features of the far side of the moon is the South Pole-Aitken Basin, a massive impact crater that is over 2,500 kilometers wide and 13 kilometers deep. This ancient impact basin is thought to have formed during a period of intense bombardment in the early solar system, and could provide valuable insights into the composition and structure of the moon's interior. In fact, data from NASA's Gravity Recovery and Interior Laboratory (GRAIL) mission, which orbited the moon in 2012, revealed that the South Pole-Aitken Basin may contain a huge mass of metal beneath its surface. This discovery has sparked speculation that the moon's interior could contain valuable resources that could be used to support human exploration and settlement. Overall, the exploration of the dark side of the moon is an exciting and important frontier in space exploration. Through a combination of robotic missions and human exploration, we are gaining new insights into this mysterious region and unlocking its secrets. As we continue to explore and learn more about the moon and beyond, we are expanding our knowledge of the universe and pushing the boundaries of what is possible.